Physical and chemical changes. We come across many changes in our day-to-day lives. Some of these changes are permanent and cannot be reversed. Example, once milk is converted to curd, it cannot be converted back into milk. But when you stretch a rubber band, it can regain its original shape and position. Such changes are referred to as temporary. Thus, permanent changes can be classified as chemical changes and temporary changes as physical changes. Let's study about them. Physical changes. Physical changes are most of the times for a short span of time. Better, we can say these changes are temporary and can be reversed. Physical change can be defined as: a physical change is the one that changes the shape, size, physical state or appearance of a substance but not its chemical composition. Examples of physical changes: stretching a rubber band. If we stretch the rubber band, it will observe that the length, shape, and size of rubber band changes. Now, release it back. It will come back to its original size. Thus, the change was for a short time, that is, temporary, and was reversible as it regained its original form. Melting of solid and freezing of liquid. The cubes of ice melts to form water at room temperature, but if water is kept in a freezer, in ice former, the same amount of ice and same number of cubes will be formed. Thus, we conclude that the change is temporary and reversible. Properties such as shape, size, color, and state of a substance are called its physical properties. Characteristics of a physical change. The change is reversible and temporary. No new substance is formed. No loss or gain of energy takes place during a physical change. No change in mass occurs during a physical change. Other examples of physical changes: formation of dew, drying of wet clothes, breaking of glass, crystallization of sugar, beating aluminium to make aluminium foil, cutting of nails. Chemical change. We have all seen our mothers setting curd from milk in night, and by the early morning we obtain curd. This is a pure chemical change. A change in which one or more new substances are formed is called a chemical change. Note: a chemical change involves a chemical reaction. Let us all try to understand chemical change through this example. Characteristic of milk, liquid, contains lactose sugar, free-flowing, sweet to taste. Properties of curd, solid, contains lactic acid, fibrated texture liquid, sour to taste. Inference: change in composition, change in texture, and change in properties. Hence, conversion of milk to curd is a permanent change. It is an example of chemical change because new substances are formed which have different composition and properties. The change is permanent and irreversible. The products formed are entirely different from the initial substance. Another example which can be studied to understand the nature of chemical change is rusting of iron. When iron is kept in air for a long time, it gets rusted. Bright and lustrous surface turns dull with no luster. Change occurs in its composition. Iron to iron oxide is formed. Solid substance changes to powdery substance. Element changes to compound. Thus, we see that iron gets a coating of oxide in its surface, due to which it loses its luster, change in composition is observed, and the change is permanent and irreversible. Thus, in above activities, we observed that one or more new substances are formed with new and different chemical properties. Characteristics of a chemical change. The chemical change is irreversible and permanent. The composition of a substance changes during a chemical change. Either heat is absorbed or evolved during a chemical change. Total mass of the system remains the same. Examples of chemical change: rusting of iron, burning of candle, digestion of food, clotting of blood, photosynthesis, removing cream from milk. Differences between physical and chemical change. Physical change. A physical change is temporary. A physical change can be reversed. No new substances are formed during a physical change. No change in energy takes place. Composition of a substance remains same. Chemical change. A chemical change is permanent. A chemical change is irreversible. New substances are formed during a chemical change. Energy is either absorbed or evolved. Composition of a substance change during the chemical reaction. Chemical reactions. Whenever a chemical change takes place, it is accompanied by a chemical reaction. These chemical reactions are usually represented with the help of chemical equations. The reactions taking place in chemical changes are classified into several categories. Direct combination or synthesis reaction. When two or more elements react to form compound, the reaction is known as synthesis reaction. When hydrogen combines with chloride, hydrogen chloride is formed. Some more examples. Magnesium reacts with oxygen to magnesium oxide. Carbon reacts with oxygen to form carbon dioxide. Decomposition reaction. When one substance breaks down into two or more simpler substances, the reaction is known as a decomposition reaction. Mercuric oxide decomposes to form mercury and oxygen. Water electrolyzes to form hydrogen and oxygen. Displacement reactions. In displacement reactions, a more reactive metal displaces a less reactive metal from its compound. Iron is more reactive than copper, so it will displace copper from its place. Copper is more reactive than silver, so it will displace silver from its place. Double decomposition reactions. A reaction in which the cations and anions are exchanged is called a double decomposition reaction. Silver nitrate reacts with sodium chloride to form silver chloride and sodium nitrate. Barium chloride reacts with sodium sulfate to form barium sulfate and sodium chloride. Neutralization reaction. When an acid and a base react to form salt and water, the reaction is known as neutralization reaction. Sodium chloride reacts with hydrochloric acid to form sodium chloride and water. Rusting of iron. Iron is one of the strongest metal which possesses a high tensile strength, with one disadvantage, that the metal undergoes corrosion very easily. Corrosion of iron is known as rusting. It is the process which affects iron particles and slowly eats it away. The tough and strong metal, that is iron, gets covered with powdery substance known as rust, which gets removed from the metal. As a result, thick sheets of iron reduce to thin sheets. Word equation for rusting of iron. Iron reacts with oxygen and water to form hydrated iron oxide or rust. For rusting, the presence of both oxygen and water or water vapor is essential. If the moisture content is more, it will lead to more rusting. Methods to prevent rusting. Paints and grease. Paints and grease prevent the articles from coming in contact with oxygen or water or both. Hence, if either of two is absent, rusting doesn't take place. Galvanization. It is the process in which a layer of zinc or chromium is deposited over the iron sheets. By alloying. Another way to prevent rusting is by alloying. Iron is mixed with some other elements like chromium, nickel, manganese and carbon, which enhance the properties of iron. Crystallization. Seawater contains large amount of dissolved salts. It can be evaporated to produce sodium chloride crystals. But the crystals obtained in this manner are not pure, small in size, and cannot be seen clearly. In order to obtain large crystals of pure substances, the solution has to be concentrated and then cooled. This type of crystallization will yield prominent crystals. The process of obtaining large crystals of pure substance from a concentrated solution is known as crystallization. Thus, method of crystallization separates a pure solid in the form of its crystals from a solution. Crystallization technique is better than simple evaporation technique, as during evaporation process some solids may decompose and some, like sugar, may get charred when solution is heated to dryness. Some of impurities are so small and they may remain dissolved in the solution even after filtration. On evaporation, these contaminate the solid. Amorphous substances. Those substances which are powdery and possess no definite geometrical shape are known as amorphous substances. Example: talcum powder. Crystalline substances. Those substances which are hard and possess definite geometrical shape are known as crystalline substances. Example: sodium chloride crystals, crystals of copper sulfate.